Okay, so it's a great pleasure to welcome my friend, Yancy Dong, and he's now a PI leader at of the neuro-symbolic group at Fraunhofer in Germany. And in the past, you have worked a lot in this field. You have been quite a pioneer in neuro-symbolic, and also you have worked on many other aspects of AI. And I remember to have seen a book from you, no? It's that you have published a few years ago. 2 years ago. That was and you have been in Cambridge several times as a visitor, so we really happy. Now this is very interesting because it's something that has some relationship with ChatGPT that you will tell us, and you think is a very new direction that research can take from that. That is, I'm sure, for instance, Max has worked on large language models and so on, so that would be. Please.
Okay, thank you for the nice introduction. The title of my presentation is Sphere Neural Network for Higher Level Cognition. And the two collaborators from Cambridge is Mattia and Pietro. Let me move on to the outline. So I will give actually 4 parts. The first, I will give a general introduction of higher level cognition. I will convince you that sphere configuration and the motion of sphere configuration is necessary and sufficient to model high level cognition. And then we move on to look at a micro world, say syllogistic reasoning, how syllogistic reasoning bridges the low-level spatial reasoning with domain general reasoning. And then is the technical part. We should design a new sphere neural network that determines the validity of all kinds of atomic and syllogistic reasoning. And we show that this network can use just one iteration to determine long chain syllogistic reasoning. And in the last part, I will show the power of sphere representation. It can do not only syllogistic reasoning, it can do a variety of logic deduction and even Bayesian statistics. Okay, so let me move on, starting with the classic experiment from Thormann's experiment with the rats. So Thormann has raised a lot of maybe clever rats. They are getting starved for 2 or 3 days. Then they put on the device location A, and at the end of location H is the piece of cheese. So these rats will go through the channel and move to B, and then they're square. Then plus they should orient themselves and find a path, the ladder to climb up, and then turn left, turn right, and then turn right, then get to the food. And they repeat the experiment for several times till the rats remember the route. Then the experiment, he replaced the device with a new device. So there are a lot of channels. Okay. And then he found some clever rats can find shortcut to get to the cheese. Okay. And then Thormann's argument is that why the rats is able to find a shortcut is they construct a map in the learning phase, so that when the environment change, when new paths exist, they just get the shortcut. And for high-level cognition, we show the cognitive agents or not rats, but people, to be able to describe a shortcut, describe a route, and even to follow router instructions or even traffic rules to guide the navigation. And the whole should be implemented or realized by a neural model. The question is the traditional deep learning system can do all of them, or we need to do some extension? And our solution is that we need to do some extension. We need to extend the vector representation into a sphere representation. And then let's move on. Let's start with the thought experiment to motivate our solution. So suppose you are in front of a maze, okay, more complete than the rats scenario. And then you are giving a router instruction. So how to pass through the maze, and then I tell you, just follow this router instruction. Either if the router tells you move forward, you just move forward. Turn left and turn left. And the trick is that the route is not complete. It guides you to the middle of the maze and help yourself. And what would you do? What can you do? At the time, when I designed this thought experiment, I asked GPT-3, I'm lost in the maze, can you help me? And he answers very beautiful. This is a very nice maze and sparkling and beautiful. I love the maze, and could you help me find a way out? So although it doesn't help me, but I like the answer very much. And recently I tried the ChatGPT, say, I'm lost in the maze, can you help me? And this time it's very professional. It said, I'm happy to help you, and could you provide me some more detail about the maze, and such on. And I answered that's a normal structure of maze, just one entrance, one exit, and a lot of ways are all similar. What can I do? And so that's great that the GDP continues to give me general tips. The first is keep one hand on the wall. That's a classical strategy to navigating in the maze. It's just a wall follower algorithm. That's a correct suggestion. The other two are also correct. Mark your path, and the third is to look at landmark. Although in maze may be harder to find landmarks. But anyway, the first suggestion is totally correct. So, but for me, I need to find the correct instant router instruction. So I think about, could we design a neural navigator using the existing paths? Say, I mask some router instructions and to predict this from its neighborhoods, just like we do word embedding. Okay, so we cover 6 router instructions to predict left. Okay, we can train a neural network to do this kind of job. So we start from the first router instruction to predict the second, and then use the first 2 to predict the third, and so on. Till in the end, it tells me, well, what should I do in the next? Would you buy this neural navigator? Nobody, actually. But however, if we think about this is not a router instruction, it's the music notes. So there are 12 music notes. Then the task turned out to be someone is writing a music sheet, but it's not finished. And we use deep learning to finish the unwritten parts. Okay, and this is the Beethoven X AI project, because the Beethoven's 10th Symphony was an unfinished one. And there is an AI project to use deep learning to finish this symposium. Let me see whether I can play the music. I'm sorry, you can listen, you can have a try on YouTube. So why? But people buy the CD and will not buy the neural navigator. And what is the reason? Because at the beginning, I showed you a structure. You know the next router instruction is determined by the structure, not by the past routes. Okay. And also, if I say I train this neural navigator by using maze all around the world, but still cannot convince you to buy the products. That's actually router generation is just a function of system 2 of our mind. Okay, which follow rules, follow structures. But enjoying music is a system 1 function. It's just to make a harmony, to make a coherent story, and do not take care of logical structure. And I believe you definitely know this book. So what I'll say is that training data cannot replace the role of structure. The question is, how could structure be represented in our mind, and we can also simulate it. Let's back to Tolman's experiment. The rats are running through the channel. It's somehow similar our driving in a highway. Let's start from San Diego and driving north, and then further north to Los Angeles and turn west at San Francisco and turn east at Sacramento, that's California, and then cross the border to Reno, that's Nevada. People are asked what's the relation between San Diego and Reno. What do you say? What would you answer? That's okay. Most is the west or the east. But when I show you this problem, most people say, you will say it's west, right? But actually it's true. If I do not show you the diagram, most people say San Diego is further west of Reno. Okay, because they know San Diego is in California and Reno is in Nevada, and California is west of Nevada. And if we using this 3 triple to train a neural network, a traditional neural network, we will also have the relation. San Diego is west of Reno, okay? And we are happy that they can do analytical reasoning. But here is the map. Here is San Diego, here is Reno. Okay, it's not, so there has a distortion. There's an error. And for error, for engineer, error should be repaired and should be removed, okay? But for psychologists, errors is a window to explore how mind works. And there are 2 psychologists, Stevens and Cooper. They examine why people make systematical error that's to misjudge the relation between San Diego and Reno. And their conclusion is that spatial location is represented in our mind in terms of regions, not vectors. So in a partial tree structure that San Diego in California, San Diego is a region inside the California region. The Reno region is inside Nevada region, okay? And when they do not have the explicit knowledge between San Diego and Reno, they just inspect the construction model and inherit the relation from their parent node. Okay, and you say San Diego is also west of Reno. So the reasoning of our mind, as many as the mainstream psychologist research show, is a process of model construction and inspection. Okay, and the work I reference here is Marco and Knopf's work in 1913. So what we learn is that these vector embeddings will be blown up into a sphere embedding to encode the spatial relations. So these two should be unified into a sphere configuration. And then from this configuration, people inspect the relation between San Diego and Reno. Okay, so let's move on to look at how the powerful of sphere configuration could be. If we replace San Diego with doctor and California with home, then it would be a doctor at home. It's also a part-whole relation. And patient with Reno, a car with Nevada, then the patient in the car. Then we have a street scene. And from this, if it's a doctor of a wife, then if the patient asks, is the doctor at home? We would expect the patient will visit the doctor, okay? We just see. And then if the pretty wife answers the doctor is not at home, then we would expect the patient may get on a car and go home or go away. But the pretty wife answers, come right in. And then they become a love affair. And that's essentially humor. What I describe is a diagrammatic representation of a classic joke in the humor literature. So what is humor? The incongruent theory of humor described it consists of two scripts, okay, two events. The first one is the common sense one. And then the second one is the violate our common sense, is construct one. And there's an overlap. And the person or the object have opposite features in these two scripts, either winner to loser, or non-sex to sex, or live to death. So all these we can represent as the rotation of the sphere, if we're using sphere to represent them. Okay, the patient has a non-sex feature. In the second event, it turns into another feature. And doctor as a winner, as a superiority. In the second event, it's a loser. Okay. So it's a motion of sphere structures or describe the understanding of humor. So let me just quickly summarize the first part, the power of sphere configuration and the motion of sphere configuration. On the rats, we know there's a configuration of environment, and then we move on to San Diego Reno case. This should be a model construction and then inspection to reasoning with unknown relations. And then we move on to say the rotation of sphere, we can capture the understanding of humor. So the process is the basic is spatial cognition, and high level, the highest level of cognition will be humor understanding. And the theory support them is say spatial thinking is a foundation of abstract thought. The book is written by Barbara Tursky as a mind in motion. And now we should question how spatial thinking connect with abstract thinking. We can back to the case again. If we say California is west of Nevada is one kind of disconnected relation, and San Diego is inside California. From these two, we can deduce San Diego disconnect from Nevada. And then Reno disconnect from Nevada and San Diego disconnect from Nevada and Reno inside Nevada. We can deduce San Diego disconnect from Reno. So this is just 2 times of syllogistic reasoning. Okay. So that's the reason we interested in syllogistic reasoning. The spatial model can directly used for domain general and syllogistic reasoning. And in the literature of psychology, this syllogistic reasoning is taken as a micro world for human and rationality. Okay, here is some reference. So we briefly introducing what is syllogistic reasoning structure. It's a very simple reasoning. It just has 2 premises. Let's say all Greek are human or human are mortal. And from the 2 premises, we deduce 1 conclusion, say all Greeks are mortal. And totally there are 3 concepts. And relations are limited to 4 relations. All X are Y, no X are Y, some X are Y, some X are not Y. If they give them a name, affirmative universal, labeled with A, negative universal as E, affirmative existential I, and negative existential O, then we can label each statement with O, and then this is AAA type. And then people will give them a name, the Barbara type. Okay. So let's say, could ChatGPT do syllogistic reasoning? Yes, they do, and do quite well, actually. Is the following syllogistic reasoning valid? No M1 are S, all P are M1, therefore some S are not P. And I just used the API to call ChatGPT 3.5. It just answered yes, it's always true. It follows the form of Barbara in traditional Aristotelian logic. Actually, the all are perfect. What's missing is this is not Barbara type, right? I just said Barbara type is all S are M, all M are P, therefore S are P. And this is another type, but general is correct. If we take a longer, long chain question, then it can make a mistake. For example, is the following syllogistic reasoning valid? Some S are M1, no M2 are M1, some P are M2, therefore no S are P. Then it answers yes, its reasoning is true, and then this is a incorrect answer because we can draw a counterexample to refute the conclusion when no SRP, when in here S and P are partially overlapped and all the premises are correct. This is also should be replaced. So, but the problem here is that if we training with symbols or words, there's always out of distribution data. For example, if we trained with these all Greeks are human, then it should work well with Italian or French or Germans, but may not work well with Dani people. Okay, maybe not in the literature or Google media people. Okay, then one method is to replace these words with diagram. Let's say all Dani people are human. It's not a relation between 2 vectors. If we argue these entities better represented as region, then we should hope that the human region should contain the Dani people region. And their century vector, the orientation of the century vector is not so important in this to capture this relation. Important is their boundary relation. Okay, so we remove them They can move anywhere, and then they change the orientation. But anyway, all dynamic people are human in the whole. So in here, we're just using, instead of using vector to carry that features, we're using boundary relation to capture topological relation. And this is also just the lesson we learned from the San Diego Reno case. Blow up the vector embedding into sphere embedding. Okay, and actually the idea is not new. So then we translate the syllogistic statement into a relation between two circles. So all Greeks are human. We're just using two circles to represent the statement, and then using different color to represent concept. And this is the traditional implementation by Wang and also student of Pietro and Mattia. And using enough training data, this network works very well. It reaches 99.8 accuracy. Question is, let's suppose it's 100% accuracy. Could we say this neural network learns syllogistic reasoning? We did an experiment to a well-trained OLAnet. Instead of giving two circles, we just feed them two green circles. This is incomplete input. For logical reasoning, the system should not give any conclusion. But if we change the size and location of the two green circles, sometimes the network will say blue contain red. What happened? Because this two green circle will be transformed into a vector. And this vector, if similar to a vector in the training stage that contains red and blue, then they will activate a result between the red and blue. And this feature for object recognition, it's a good feature. It means if the object is partially covered, and the neural network can still recognize the object. But for logical deduction, it may not good, because this means the system will automatically feel missing component or premises in the training set. This is for logical deduction, not allowed. Okay, and for this neural network, we cannot stop this. It just do automatically. So the idea is, how can we repair this? One way is that we define a single circle input is invalid. Okay, we collect this input and say replace 0, 1, 0, 0 with 0 or 0. Okay, then we collect a lot of training data to train this neural network. And we did this. And it works well. When we single circle input, it just tell you it's invalid. Then the question is this improved? And OLAnet can do syllogistic reasoning? No. You're correct, it's no. Why? Look at this input. One green circle with half red, half blue. The system will have difficult to say the half red is the full red circle covered, how the other half is covered, or the half red circle is noise. We did experiment. Some case it completes the other half, so it's valid. The other case is that it's invalid. So to exclude this situation, we need to create a training data again to say one green, half blue, half red is invalid. And the problem is that this process will never end. After we decide this is either valid or invalid, then what happens with one blue with one false red? Still undecidable. So the problem is that the training data itself creates undetermined inputs. Okay, so we have to abandon this methodology for logical reasoning. For object recognition is fine. So what we do is that we need a construction model. Okay, instead of to do pattern matching. Now the question is, these are reference from Johnson Laird and then Marco Magni and Marcus Knopf. So let's say, let's give in a valid syllogistic reasoning and see what kind of neural net we want to have. So the input is two premises. Some lawyers are presidents, no presidents are scientists. And the conclusion is some lawyers are not scientists. And this deduction is valid. We should construct a model to prove this neurally. So the two premises will be replaced by diagrams. Let's say some lawyers are present is the blue circle, red circle and green circle. So say they are partially over, at least they connected. And no presents are scientists, the two circles should be disconnected. And the conclusion is some lawyers are not scientists. That means they are they partially overlap. Okay. Then the neural network should construct or should resize the circles and locations to satisfy all the three conditions. This means the global loss should be 0. And if we, so the first criteria, global loss equals 0. But even we do achieve this, it's only a satisfiability problem. It's not valid. It say it can be. What we valid says the negation of the conclusion cannot be true. This means valid. So the negation of conclusion is all lawyers are scientists. This means the green circle is inside the purple circle. If this is impossible, then the two premises with this conclusion, these three relation cannot be satisfied totally. This means this time the global loss should be greater than 0. So we add the second criteria. We cannot do this. The reason is the global loss greater than 0. This condition is too weak. Probably the weakest conclusion in neural training. Any neural net, we take it, don't train it, it's satisfied. The point is that we need to guarantee no matter how many time iterations, it will never reach 0. So instead of we using this criteria, we strengthen the first criteria. We say if the three statements are satisfiable, the neural network should reach global loss 0 within a constant number of iterations. And we need to prove the existence of this constant number. Okay, then we can say, and the negation cannot be true, means after this constant number is still greater than 0, then we stop. It's unsatisfiable. Okay, so the criteria is quite strong, but it exists. what we do is that first we need to do a mapping, a one-to-one mapping from syllogistic statement to qualitative relation between spheres. So all x or y mean sphere x is part of sphere y. Okay, no x or y means sphere x disconnect from sphere y. Some x or y means we use negation. This means sphere x does not disconnect from y. If we're using positive relation, then it's not one-to-one mapping. They can partially overlap, one contain the other, or the other contain the first one. Okay, we need one-to-one mappings. And the last, some x are not y means we were mapping it, the sphere x is not part of y. Okay, then if we have a symbolic syllogistic statement, we just translate into one qualitative spatial relation between spheres. And then we can look at when two spheres are coincide, equal, it's already satisfied two conditions, all x or y, some x or y, so quite easy. And we move a little bit, it satisfies some x or not y. If they are disconnected, then satisfy no x or y. Yeah. So in this way, non-cyclic syllogistic statements are always satisfiable. We can construct a model. We start from the first one and then move it till the first relation satisfied. And then repeat the process. It's always doable. Yeah. The question is, where is the motor? Which force pushed the sphere to move to satisfy the criteria? We need to design a neural approach to gradual descent approach to reach the target. So let's suppose the current status relation is partial overlap, and we will reach the target is the disconnect. And let's always fix the V, sphere V is fixed, X is movable. Okay. So first because it's in embedding space, the relation, whether they are D or PO can be computed or can be measured. Disconnect means the central distance is larger or equal to the sum of the radius. Okay. If we define the open space, open sphere. Then the gradual descent is, we define this kind of symbol, means the bottom symbol means the current state should move to the target. The D behind the PO means the neighborhood relation on the route towards the target. So it always moves to the neighborhood relation. If we define the sum of radius minus the distance between the central point. So we need to decrease the radius or increase the distance. Okay. Then the X sphere should getting further away and disconnect from the reference, the V sphere. When it's 0, it's exactly disconnect. Because they are the two vector X and the distance between central point, they are changed independently. So it can cause problem. For example, in this case, if the radius decrease too fast, it can be get inside part of it, not get disconnect. So in this case happens, we need to first let the central point of the X sphere move out of the V sphere. First move out of it, then do so the PO relation is this sphere after that to be shrinked to getting disconnected from V. Yeah, okay. And the same for the containment relation. If the two spheres are partially overlapped, we want the X sphere contain V sphere. This means we want the distance between central point getting closer, and the radius of X be larger than the radius of V. Okay, and then also plus the radius R. If the radius of X enlarge too slow, it will also get into inside of it. So the method is that we first enlarge radius to equal to the radius of the reference, and then do this. Then do simultaneously update the central distance and radius. Okay, this is the total whole transition map that used to reach one relation, one target relation. Syllogism has 6 targets: disconnected, inverse disconnected part, inverse part, and negation. We start from equal because it's the easiest. Okay. So syllogism, we have 2 premises and 1 conclusion. The 2 premises is we always can realize it, construct model. And the conclusion may not or maybe, but when we realizing this relation, we should keep the already constructed relation without being broken. So what we do is that this also can cause problem. Let's see an example. For example, the Y sphere should be inside X sphere, and Y sphere should disconnect from Z sphere, and this is correct. If the conclusion is Z sphere should also inside X sphere, then it moves into the X sphere and touches the Y sphere. And this relation between X, Y is broken. Between Y and Z is broken. Let's remember what ChatGPT tells us. Keep one hand on the wall. And this is the classic strategy for navigating in maze. In this way, the Z sphere should keep the hand on the Y boundary. Okay, touch it and then move. This means it should move it and then move. And we should design a neural computing, a gradual descent and process to realize this, follow the wall. Okay, and it's possible. Let's do it. So the starting point is that we assume the 3 central points of sphere are non-linear, are non-collinear. And then we fix X and Y, these 2 spheres, and then optimize the Z sphere with the relation to X. I need to keep the relation between Y and Z. Okay, what we do is that the objective function is the sum of the loss between X and Z and Y and Z. Okay, we compute the sum. And then we do backpropagation. Because the Y and Z relation is optimized, so the cost is 0. It just moved towards the central point of X. When the YZ relation is broken, the loss YZ loss will be greater than 0. Then we do a reparation. We only repair this YZ relation. In this case, we ignore the existence of X sphere. So in that case, it moves along the century point between Y and Z. Okay. Until YZ relation is repaired. So again, 0. And this process may increase the loss between YZ. What we need to prove or need to show is that this loss of increase should not greater than the reduced loss of Y and Z. Okay. And then we can say this representation, the gradual descent of the sum plus the representation, this whole process is monotonous. And the reason is because the century point is not on the one linear. So the reduced loss YZ is multiply cosine alpha is the increased loss of XZ. So it cannot be greater than that. So then we can decide after one loop, if the loss between X and Z is greater than 0, but less than the sum of the loss, then we loop to the second step. If XZ the loss reaches 0, we find a solution. If XZ loss equals to the sum, equals to the loss before the reparation, and greater than 0, stop, no solution. We can see an example. Here is a non-solution example. Let's say X disconnect from Y, and Z is inside Y. We want Z also inside X. It's not possible. Let's see how the constraint process will work. It first move to the century point till tangentially part of Y. Then broken the relation, repair it, and broken, repair, broken, repair, broken, repair, broken, repair, broken, repair. So it works just like, let's say, it just follows the inside wall of Y, okay, until the point that's closest to Y. And at that point, if you reduce the loss to the Y and to the X, and broken the relation with Y, and after repair the relation with Y, the cost and the loss just equal. And the formula just before reparation is delta XZ plus delta ZY. After reparation is delta apostrophe and ZX, they are equal, greater than 0, so stop. Okay. But when this constraint operation fails to find a solution, it may still have another configuration that satisfies the relation if we update, if the original fixed point XY changes its value. That means when the original XY are negative relation, say X cannot be part of Y. If they are implemented by partial overlap, then if Y, all Y are Z, then the Y should contain and will be inside Z. Then the last criteria is X disconnect from Z. In this case, there's no solution. If Z contain Y, it must touch X. Okay. When this happens, means the negation of the relation between X, Z must be valid. So if we start from fix the Z relation and to implement the other two relations, then the negation P relation must be broken. So in that case, we just fix Z, let X disconnect from Z. Just move out of it. And then all the other two relations are satisfied. This means if the three relations are satisfiable and the constraint optimization fails to find a solution, it needs one-time restart from the third sphere. Then it must find a solution. So the SphNN can determine the satisfiability of cyclic and syllogistic statement this way. It first implement the n-1 relation, then fix the first sphere as n-1 sphere to see whether the negation of the last relation can be realized. If can, it finds a counterexample to refute the validity. And if not, it should observe this relation. It should update, go backward. So if not satisfiable, then it should fix the last sphere and the second last sphere to update the sphere 1, the first sphere. If this is a relation, observe the relation between first sphere and n-1 sphere. After this update, this relation must be broken. Let's say it's changed to relation R. Then we need to define what is the syllogistic relation between first sphere and n-1 sphere. Okay. So if R is D or P, then it's the same. We just use this one. If R is PO, we need to think of, because PO is not a syllogistic statement, we must replace it with negation. So we look at the original version, negation. If D, then negation D, P or negation P. Then we reduce the problem that the cyclic statement with n relation to n-1 relation. Okay. So first do this, and then if unsatisfiable, then we fix this, we figure out this value and this value. So in general, we need one epoch, and within this one epoch, we need n squared times computation to decide or to construct a model or to decide it's or to refute it's invalid. Okay, so the last part. Sphere model has lots of strong representation power. If a sphere is the set of points, and that the distance to a central point is less than a constant, that's the sphere. So it's in three-dimensional sphere, where it's just a ball, it's a 2D, then it's a circle. If the radius equals 0, it's a point. And if we define sphere along a line, then the sphere is a segment. And the interesting thing is that if the space is a circle, a sphere is an arc. And this is particularly interesting because the negation of the set is also an arc. So we can introduce in complement set into neural computing. So here are 32 variant of syllogistic reasoning. I just take one example. A quite interesting one is a disjunctive syllogism. And because recent research showed that monkeys has the capability to do disjunctive syllogistic reason. Okay. And how they do that? They definitely not training with a lot of data. They are constructing model. How can we represent this using arcs in a sphere? So first, fx is, let's say, is an arc in a circle, and gx and hx are also two arcs. Then, if x is in the fx arc, it must be inside the gx arc or hx arc. So if this is the hx, this is the gx, and if this is the fx, then this neural network should let the arcs rotate together so that their union should cover the red arc. And then if fx, then it's not inside the gx, so it should be shrink. It should be shrink until only it's not inside the g, negation g. Then the conclusion is fx must be in the fx section of the arc. And we can say the thinking of the monkey can be simulated by rotation and the resizing of 3 arcs. Okay, and again, this thing, mind, emotion. Bayesian reasoning is also quite interesting. If we say the perimeter of a circle is 1, then this arc represent event. Then it can say the arc is the length of the arc is the probability of this event. Then we can compute, and the probability of D with the condition of A is the intersection of D arc of A arc divide the length of A arc. Okay, and we can compute the Bayesian formula. Here is an example. 1/4 of all animals are birds, 2/3 of all birds can fly, half of all flying animals are birds. Birds have feathers. If X an animal, what is the probability that is not a bird and it cannot fly? It's a Matthias example. Let's try this method. We can design a neural net with say 1/4 of all animals are birds that can 1/4. 2/3 of all birds can fly. They can fly, cover 2/3. And half of animals are birds. They can do birds. So the question is to say, what is the length of the rest of the arc? Okay. So the interesting is that in this way, the logic relation between arcs are about connecting this relation between arcs. And statistics relation is about to which degree they overlap. So in that case, logical reasoning and stat reasoning can be unified around these arcs. The last point, what happens to syllogistic, to heterogeneous relation? Let's say San Diego is part of California, is in California, and San Diego is a city, is a category relation. If we're using sphere to represent them, then if the sphere represents part whole, it cannot represent its relation. So the method is just using two spheres. Then a city is represented by a sequence of spheres. Okay, it's easy. So I just summarize what I'm talking about. The first is first part is high-level cognition. We start from rats and then say the structure of the environment in our mind is take region as component, and then we show this can have strong power to represent for spatial reasoning to humour understanding. And then we focus on syllogistic reasoning and dive into the syllogistic reasoning. We using sphere model to carry out reasoning through a model construction. And then we design sphere neural network and show traditional neural network cannot reach determinacy. And then using neighborhood transition, we realized a sphere neural network that can determine the validity of long chain reasoning with one epoch and the computational complexity with n square. And then the last is show the representation power of spheres. I hope it's over time. Okay. I have experiment, but I think I'll take some question answering, and then if you're interested, we can continue. Will be that good or?
Yes, sir.
Okay.
Good question. I have an idea I will discuss later for an MPhil project about this. It will be something very special. Also, you may design some large language model to retain this.
Yeah. Because I have an experiment to say ChatGPT or large language model. They can give a correct answer, they're true, but the explanation is not correct, or the other way around. But they do provide us a way to construct model. So we just take this instruction to let this sphere neural network to construct the model to see whether the answer of ChatGPT is correct or not correct, and give feedback to the large language model and let them improve the result. Okay, and so this network can, and this is automatic process. So they can improve the performance of large language model. The problem is that the prompt engineering, there are some cases the ChatGPT just ignore the feedback. You say it's wrong, it continue its own way. So I have also an experiment to say whether the vectors from the large language model can taken as the orientation of the sphere. We just taken, then it's easier to construct sphere, to construct models. Actually, the experiment is positive, very positive actually. This means we don't need to search all space. We just take the central point of a large language model. We roughly know the sphere in which direction. And then we just change the length of the central vector and the radius to construct a model. It's much faster than without this information. Actually, it's a lot of work.
It's completely new direction, so you can solve the validity.
Yes. So before that, we need to let's say the meaning or the interpretation should be well designed, and then the meaning. Let's say I take the syllogistic reasoning, so the meaning is the using the Euler diagram to represent the semantics of logic. Then for other, in the humour case, then the event, we should also describe a spatio-temporal model. What is the start of the event? What is the middle? What is the end of the event? We can do similar reasoning. Actually, syllogistic reasoning is basic for an event reasoning or deduction.
Bertrand Russell didn't like it.
Yeah.
Do you want to summarize what else you have?
Yeah. The summarize is that we let's say what's new here is that we promote vector embedding into sphere embedding and introduce the reasonings using model construction into the neural computing. Not that we actually using region to do a logical query. It is a lot of work, but most of them just using pattern matching methodology. It's not a model construction model, a methodology. So they cannot decide the validity of such kind of strong results. Such like that. Sphere moving to simulate the thinking. Yeah.
Move the spheres by the camera conversion.
Convert. Yes, we need to design. Yes, it's stuck somewhere. Then I just try to argue that when it's stuck, for if it's non-zero stuck, then say the original statement is unsatisfiable.
Yes, so
Yeah, we must prove that.
yeah.
Okay, because so when it's stuck, let's say it's rotate. If rotate is still stuck, restart from another sphere. If using these two steps still stuck, unsatisfiable. Okay. Yeah.
Thank you.
Thank you. You stopped recording?
I'll do this.